What up, it's your boy C Rizzy coming at you with Unit 1, Lesson 7, Midpoint and Distance in the Coordinate Plane. Our essential question of the day: how can you find the midpoint and distance of a line in a coordinate plane with a slope that is 0 or undefined? And our objective is to find the midpoint of a segment and to find the distance between 2 points in the coordinate plane. Our essential understanding: formulas can be used to find the midpoint and length of any segment in the coordinate plane. Okay, so let's just start with some basic examples. So find the midpoint of EF. So the midpoint of EF is G. The question is, what are the coordinates of G? And the coordinates of G are 1, well, let's do it this way. So E is at point 0, 1. While F is at point 0, 4. So it's a total distance of 3. So what's half of 3? It's 1.5. So if I add 1.5 to my y value, I end up at 2.5. So that's my coordinate for G. The midpoint of AB is blank, or the origin. What's the origin? 0, 0. And CD has a length of 1, 2, 3. We can count it out. So the midpoint's going to be right here in the middle, which is at 0.50. Okay, those are a little bit tricky. We're going to spend more time focusing on what is the midpoint formula, not on a number line, but more on in a coordinate plane. So here's our midpoint formula. Right, where you have two coordinates, x1, comma, y1, and x2, comma, y2. Right, and that's where we get these variables right here. Okay, so here I have a line. So there's a couple ways we could do this. So I have the point 1, 2. I have the point 17, 4. So what they say here is that if you add your two x values, 1 plus 17, and your other set of y values, 4 and 2, and then you divide them by 2, you'll get your midpoint. So 18 divided by 2 is 9. 6 divided by 2 is 3. So that's how you get your midpoint. Again, we're not really focusing on the number line problems. Okay, so again, the midpoint of AB has coordinates of 4, negative 9. Endpoint A has coordinates of negative 3, negative 5. What are the coordinates of B? So this problem is a little bit different. Okay, so in this problem, we're given the midpoint first, and then we're given an endpoint. All right, and there's a whole big long formula of how to follow this. So what it says is that your endpoint of A is at negative 3, negative 5. You plug them in over here. Then you would plug this in over here. Okay. So you get x1 plus negative 3 divided by 2. This is already super confusing, so we're not even going to do this. We're going to move on to a different example. I'm going to show you how to do these problems. Okay, so again, so midpoint means middle, right? So if I have an endpoint A at negative 3, negative 5, I have a midpoint at 4, negative 9. I want to find the other endpoint, which is B, right? So think about a line, right? Here's A, here's your midpoint, here's B. And what you know about a midpoint is that it divides a line segment into two equal pieces. So my change in my x's and the change in my y's should be exactly the same. So if I go from negative 3 to 4, what do? We added 7. Negative 3 plus 7 is 4. I'm going to do that again. 4 plus 7 is 11. So there's your x coordinates. And now we'll do it from y. To get from negative 5 to negative 9, you're going to subtract 4. So then we're going to do it again. negative 9 minus negative 9 plus negative 4 is negative 13. And here's your answer. So instead of doing the whole big formula, we can just solve it like this. Okay. Distance formula. We've all done distance formula before. Distance is based on the Pythagorean theorem, which we're going to learn in chapter 8. Okay, so here's our distance formula. You'll always have the distance formula in any sort of test. Okay, so here is a question. It wants us to solve for the distance formula. We have our x1, y1s. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're just going to plug in. So it's the square root. My x2 is 3 minus my x1, which is negative 2. Be careful here. Okay, it's minus a negative. It's not just minus 2. Plus y2, which is negative 1, minus my y1, which is 14 squared. Okay, extend this out. So then we work on these individually first. We work with inside the parentheses before we do anything. So what are we doing next? Equals. So what I'm going to do is I'm going to solve out what's inside the parentheses first. 3 minus negative 2 is the same thing as doing 3 plus 2, which is 5. 1 minus 14 is negative 15. Then we square these. Okay, remember what squared is. 5 squared is the same thing as 5 times 5. Negative 15 squared is the same thing as negative 15 times negative 15. So 5 squared is 25. Negative 15 squared, which is negative 15 times negative 15, is a positive 225. So my answer is the square root of 250. Okay, we just did that problem. Okay, so here's the part of the video where you pause it. Try this out on your own. Try to see if you can solve for the midpoint and the distance formula. Again, midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. And distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Pause the video, and then I'm going to work through it. Okay, so here's the setup for those. So if you set this up correctly, so far so good. I'm going to pause the video again. When we come back, you'll see it completely worked out. So there's all the formulas worked out. So if you got to here in the midpoint formula, there is no need to simplify this further. If you did end up putting it into decimals, it is okay. Here is our answer for distance. Distance equals the square root of 50. There is no need to work out the square root of 50. You can leave it like this. We're still going to discuss what it means to simplify a radical, but for right now, you can just keep it like this. All right, that's all from me.